Good afternoon. Thank you, everybody, for coming out. This is a bit of a fringe topic, so I know it's a fairly narrow audience that we're addressing here. So I've narrowed it down to JavaScript, and then we narrowed it down to Windows Store apps, and then we narrowed it down to Diagnostic. So I appreciate everybody that came out to see this very specialized talk. I'm hoping all of you out here are developers. We don't have a lot of IT pros in the crowd. How many of you are currently developing applications for Windows 8 Store? A few of you, okay. Are you using JavaScript? Yes? A couple? Okay. All right. So hopefully I've got some stuff that you haven't seen yet, and for everybody else that hasn't ventured down this path, we're going to have a lot of interesting stuff. What I'm going to show you is I'm going to be using Visual Studio 2012 with Update 2 applied. So all of the features that you're going to see here are all available today. We're adding some more with Visual Studio 2013, but you'll be able to use everything that I'm going to show you today. Now, I'm going to be dividing this talk sort of into two different halves. The first half is a lot about debugging and how to use different debugging approaches for different aspects of Windows 8 Store apps. A lot of this is going to apply to managed as well as JavaScript, so there's a little bit more breadth here than just JavaScript. The second half is going to be a lot more about performance and profiling JavaScript applications. All right, so the start was just, here's what I'm going to do, and I just told you about that. So we can skip over those slides. Now, one of the first things that you'll notice when you start dealing with a JavaScript-based application is we don't have quite the same tight integration from JavaScript and native that we do for managed and native. So making the transition from those two engines is a fairly difficult prospect. So if you're running applications where you're doing both JavaScript and native, and we find this comes up quite often when you're dealing with an application that has to have high performance characteristics in certain aspects. So you'll see a lot of the applications that Microsoft produced for the Windows 8 Store are a mixed mode application. So the user interface is quite often developed using JavaScript and HTML. Some of the back-end computation is done using native. So you'll see in your debugger settings that we don't have a mixed mode for JavaScript and native. So what I want to show you is how to deal with the challenges that you might have if you're writing your application with a native backend and a JavaScript HTML front end. So what I've got here is a fairly simple application. And the applications that I'm going to show you at the start here all ship with the Windows SDK. So you have access to these applications. They come as part of the Visual Studio install. Or if you just wanted to download the Windows 8 SDK, they're included with that SDK as well. So you can play around with these apps on your own. So you'll see with this application, I've got a JavaScript project, which is my front end. So that's my user interface. And then some of the back-end logic has been written using C++ in the native to gain some performance. I'll just take a quick look at what this application looks like. So it's a fairly simple app. Oh, and we can see there I've hit my breakpoint in JavaScript. And if we can just continue, we can continue to hit my breakpoint. Now, quite often, if you've got an application like this, what you also want to be able to debug is your native code. So if we take a look at loading up the native code here, and if I try and set a breakpoint, I'm getting this warning message, right? There's no symbols available because we can't debug native code within the JavaScript runtime engine. So to get around this, what you need to do, let me just stop this. You need to actually spin up another instance of Visual Studio. And what I'm going to do is I'm just going to open up the file that I want to debug. So here's my C++ file. And I can set my breakpoint on this line. I'm going to go back to my previous instance of Visual Studio. This is the one that has my solution in it, right? So my other instance of Visual Studio, I did not load the solution. All I did was open up the C++ file that I want to debug. Now I'm going to start running. Let me close this one and leave just my JavaScript. I'm going to start running my application, hit my breakpoint. I'm going to go over to my other instance of Visual Studio. Right? This is one with just my C++ file. From here, I'm going to attach to the process that's currently running. And what you want to do is you want to make sure that you narrow it down to just native code. So I've done that. There's my application. And I can attach to that application. Now you can see in my process window I'm attached to the running application. I can go back to my instance of Visual Studio that's broken at my JavaScript breakpoint. I can continue running. Now when I start to interact with the application, you can see I break at my JavaScript. I can continue, and now I break into my C++ code. And Visual Studio will take care of the transition between which instance of Visual Studio is loaded for which type of code that you're managing. Within here, I've got my call stack. You can see I've got the full call stack. I've got my watch window. I'm not watching anything. Let me just load the locals window. And here I have access to everything that's available for me in the native runtime. What you won't be able to access are the values for the JavaScript runtime, because they're actually running separately. And if I'm stopped in the native instance of Visual Studio, I want to be looking at just the native code. If I switch back over into the one that's running my JavaScript code, I'm not going to have the same access to the variables as when I stop within JavaScript. So you want to remember which code you're currently debugging and make sure that you're looking at the call stack that's valid for that type. Because on this instance, you see I don't have any call stack. If I go back to my application, let me go back to Visual Studio and continue. If I come back to my application, when I'm in the instance that's running my JavaScript, I have access to all of my JavaScript call stack. Let me bring back that locals window. And all of my JavaScript locals as well. So if you're looking at writing applications that are using both native code and JavaScript code, the way to debug it is by using two instances of Visual Studio. We'll take care of switching back and forth to the right instance of Visual Studio when you hit the breakpoints in those languages. Okay, so the takeaways from that are we don't have the mixed mode debugging support for JavaScript and native in Visual Studio 2012. You need to use the multiple instances instead, and we'll take care of switching the context to the right instance of Visual Studio for you. And when you're stopped in one of the languages, you don't want to switch to the other Visual Studio to debug what's in there, right? Because your context is going to be set correctly. Okay. Contract debugging. With Windows 8, we've introduced this concept of contracts, which you can see on this screenshot that I've got on the right-hand side. We've got the charms bar, and you've got that share, right? And these are one of the contracts that you can create, and you can implement a contract that implements, and what we'll show you here is the share, so that any user's application can using the share. So you've got a share target that users can then call into, and whatever you want to implement in your share target. So maybe you want to implement an application that shares out to Facebook, or shares out to Twitter, or shares out to whatever social media. That's merely a target that other applications can post to. So with these ones, there are a few nuances that we need to look at. And again, this is available with the SDK. So I'm going to open up a project here. It's called Share Source. This actually contains two separate projects. Typically, you're only going to develop one of these two at a time. So the first one that we see here, the Share Source, that's my application that actually wants to share something to a share source. So this is my source application. This would be typically whatever app that your customers would want to write that would use your target. The other project in this solution is the Share Target. This is what's going to be targeted by the other application. So I really have two different applications within this same solution. Now, if you're developing a target, you may want to write a simple little application for your source just to test out your target. But I'll show you some other ways that you can do some testing without having to have both projects running at the same time. So I'll just run this to give you a quick idea of what this does. So I can share some text, and if I just click my share button, you can see I've got different things that I can share with. And these are what you see on that Charms menu within Windows 8. So I could share this to Mail because I have a Mail app installed. And I also have this Share Target, which is the sample application that comes with the SDK. So if I want to share to this target, you can see I'm now breaking into Visual Studio, into my target source. And I can just continue running, and it's a fairly simple thing. Now, in a lot of cases, what you're going to do is you may not have a share source application, and all you're really interested in doing is debugging the target application because that's the side that you're building. Now, what I want to do is I just want to close this solution and open up a solution with just the target. This is the same project. I'm just opening it up as a single project in a single solution. And you'll see we have a couple of options under the properties for these. Under debugging, you can see I've got launch application. And you can actually, typically, you're going to see it with, whoop, not that. You're going to see it with yes. Because when you're debugging, you want to launch this application. Now, there are some cases where you're going to want to set this to no, because you want to actually see the interaction on how your application behaves when it's invoked from some client application. So this is a target. You can kind of think of this as like a Windows service sort of concept, right? It's something that's part of Windows 8, so it's not anything that we had before, and it's something that other applications are going to invoke. So I want to run this in a very similar manner to how it would be actually run on a customer's machine. So I'm going to say, don't launch this application when I start debugging, but I am going to start debugging this application. So I've got launch application set to no. If I take a look at my startup projects for my solution, you can see I am still going to start the project. It's just nothing's really going to happen yet. So now if I start debugging, basically I've just spun up Visual Studio into a debug mode, but my application isn't running. You can see in my processes window, I don't have any process that I'm debugging, right? So we're sort of in a dormant state. And what I'm waiting for is some client application to interact with my share target. So what I can do now is I can just come back over to my desktop, and this is actually where I do need an internet connection. Forgot about this. Let me make sure I've got an internet connection here. Okay. So what I'm going to do is I'm just going to open up Internet Explorer. And hopefully this will connect to the web. I always forget that I need the internet connection for this part. Typically what you're going to see, and I may not see it because I'm not getting to the internet, is when you go over to the share, your registered targets are going to turn up here. So this is where I would see my application. Let me just try another version of Internet Explorer. All right. Maybe I can try another app and see what happens here. No, I don't have the right type here. If I had an internet connection and a web page had come up, Internet Explorer would then be in a state that it would be allowed to share. When I go over to my share charms, there would probably be 2 different applications listed. For this particular machine, I would have my mail app like we saw before, and we would also see my new share one. In fact, I can probably do this with the SDK. Oh, here we go. So this is the share source that I was showing you earlier, except now I'm just running it as a Windows 8 application. And if I go over to my shares here, we can see it turning up on my charms. So this is how it interacts with a running application. And if I click on the share target sample, you can see I'm now breaking it into Visual Studio, and I'm hitting my first breakpoint, and I'm now attached to a process. So this is how you can actually debug a target without having a source as part of your solution. So this is giving you a much more realistic, real-world example of how to interact with those types of applications. Okay. Let's go back to our slides. So one of the new things that you're going to be able to see now within Visual Studio is you can actually configure the application to launch or not launch as part of your project properties, because you want to understand what it's actually doing as part of starting from some other application that's doing the triggering. So you're not actually triggering the launching of the application from within Visual Studio. It's a third party that's doing that initial trigger. Or you can also have a test app within there. You can F5 it or not. And then you can just invoke through the contract. Okay. The next thing that we want to look at are new background tasks. So your application can register background tasks. Now, in the traditional previous world with Windows, you'd probably run these under the task scheduler. You can just create these within Windows Store apps as well. And these can be tasks that run on some sort of trigger or maybe some kind of schedule, so it runs every 8 hours to maybe upload some files or do a synchronization with your database. Or maybe it's something that triggers on you make a time zone change, or some action within your application, or when a text message is received. So you can have a lot of different things that background tasks react to. So some of them are very simple. If you wanted to create something that responded to a text message, you just send a text message and you can debug your application. If it's something that responds to more of an environmental trigger, like a time zone change, or it runs every 8 hours, you don't want to have to wait 8 hours to debug your application. So with background tasks, we have the ability to sort of hook into those in a much more convenient manner so that you don't have to worry about waiting for that trigger to occur. I'm going to open up another solution here. So this is just a simple background task. And again, this is also part of the SDK. And we take a look at the properties for this under debugging. Again, you're going to see I'm not launching this application on startup, because I want to actually understand what happens when somebody triggers this, or whenever that event occurs that triggers this background task to run. So I start debugging. So I just F5 within Visual Studio. Again, you'll see I don't have a target process. Now, we've introduced a new toolbar. That's this one right here. the one with the process, suspend, thread. And if you're not seeing it, it depends on which profile you've started Visual Studio. When you install it for the first time and you spin it up and ask you which profile you want to use. Some profiles have this by default, other profiles don't. If you're not seeing it, this is the debug location. So once I've got the debug location, you'll see there's the suspend option. And I can go to this, and selecting from this, I can actually choose the background task that's defined within my solution. So this is just the code that's defined in my project. It's not running yet, but I want to understand how it behaves when it first starts up. So I can select that, and you'll see I'm immediately attaching to the process, and I'm hitting my first breakpoint. And you can do this with other processes or other background tasks that are registered on the machine. So you don't have to have it as part of your solution. But if you've got the code, then you can also do the debugging for it. So we've enabled this to really help you understand how to debug and how to work with code that is typically triggered from some other source, right? So this is very similar to the contracts. You need to be able to debug those under the circumstances that you would get when a third party invokes it. All right. So you can trigger them from that new toolbar, right? You just have to make sure that it's enabled, and that's the debug location. And they don't have to be running. Now, the nice thing about this, too, is you can also trigger background tasks that require some sort of payload, and you can fake out the payload. So if it requires some data supplied into it, you can still start the task, and then you can manually modify all of your local variables like you do with your debugging to modify the payload as necessary. Now, another interesting thing that we've introduced for Windows Store apps is the ability to actually debug JavaScript applications if you don't have the source. Now, you can run into these situations in a couple of different places. So you may want to debug an application that's residing on some user's desktop machine using the remote debugging tools because you're working on a newer version, or they're a couple of versions behind. It's still an application that you support, but you don't know which version that they necessarily have, but you still need to be able to debug their application without having to try and find the right version of the source code. So for this, let me just close off the solution. And let me just close this as well. So here's a little game that ships, we ship this with Windows 8, and it's a little Xbox game, cut the rope, right? So it's a fairly simple thing. I can just play this game. And this was written primarily using JavaScript. And it's got a leaderboard so I can look and see who's winning, right? So this is just pulling all from my Xbox account. Right, so this is a simple thing. But maybe my customers are saying, you know what, the leaderboard isn't showing up correctly on my version. And I'm going to try this on my app, on my desktop. It all works fine for me. I need to understand what's going on with their application. They have a different version than the version I'm working with. So what I can actually look at now is under the debug menu, you can see there's this debug installed app packages. So these are all Windows 8 Store applications. As soon as I click on that, it's going to list all of the applications that are registered on my machine. Now, if you're using the remote debugging tools, you'd be attaching to some other user's machine, and you'd be getting the inventory off of their machines. Right, of course, and this is going to require administrator privileges to do that. But you can see there's my cut the rope. And this is an unmodified version. This is the exact same version that you would download from the store. So there's nothing changed on this version. When I select the application, what I want to do is I want to make sure that I've selected script code or native code, depending on what type of code it's used. But in this case, it's script. And I actually want to stop at the very first statement that executes. So I'm going to start the application, and you see it briefly flashed up there. So the application started up, and it immediately stopped, so it broke on the first statement. And you'll see in my solution, it's loading up the JavaScript code. So I'm just going to press F10 a few times here so we can start stepping through. And you can see it's stepping through the code, and it's loading the code as necessary. So I can continue stepping a bunch of times, and what you'll see is eventually, there we go, it's starting to load up more JavaScript files. So as the application starts to access the additional JavaScript files, it's going to start loading them up into Visual Studio. So I've gone through a bunch of code, right? I don't have this code within Visual Studio, but since I'm debugging the application, it's being able to reverse engineer all of that, and it's pulling it into Visual Studio. You can see here's my leaderboard JavaScript code. And then what's interesting about this is right now it's empty because I haven't accessed any of the JavaScript from the application yet. So let me just run this. So I'll continue, get to my application. And now when I jump back to Visual Studio, all of the code is finished loading. And you can see my leadership JavaScript is all completely loaded. So I've got access to all of the code. Now I want to find out what's going on with the, my list of users. So I can set a breakpoint in this point. I can go back to my application. I can click on the leaderboards, and I'm hitting the breakpoint. All right, so I haven't loaded, I don't have access to the project. I don't have access to the source. And I don't actually even know where the source for this application came from. Right? This is just something that I downloaded off of the store. I can hit the breakpoint. I can inspect all of the variables. I can see the user list, right? And it's got one user, and there's my Xbox identity. So I can now debug JavaScript applications that I don't have the source for. Now, typically, that's not something that you're going to do very often. I'm doing this, you know, it can be interesting to understand how others wrote an application, so it's a very good learning tool as well. But it's primarily developed as a support tool for you to be able to support the applications that you've written where you don't necessarily know where the matching source is. And then when I stop, it all just goes away. Any questions on any of this so far? Okay. So when you don't have the project, you don't necessarily have the source, or you don't necessarily know which is the matching source, you can still debug the JavaScript applications using the debug installed application features. So this will, like I showed, enumerate the apps that are installed on my desktop. I can then launch them, and I can then start to debug the code. This works locally and remote if you got the remote debug tools installed on the target machine. And then with that little checkbox, you can just automatically stop at the very first line of JavaScript that executes. Okay, so that's sort of an introduction to a lot of the debugging capabilities that we've added for JavaScript and store apps. What I want to shift now into is a lot of the performance tools that we've introduced as well. So the first one that I'm going to show you is the HTML UI responsiveness tool. So this tool shows you a bunch of the work that's going on in the subsystems with Internet Explorer. Now I'm saying Internet Explorer here, but this is still Windows 8 store applications that are running on the desktop. Right? So the HTML processing engine for store apps is still Internet Explorer. So even though I'm saying IE up here, we're still talking store apps. If you watch some of the announcements that are coming out of the Build conference later today, you'll see some announcements from the Internet Explorer team about the support that they're going to be providing for some of these tools within IE for web applications as well. So this can really help you identify where the challenges are in the startup performance of your application. It'll look at things like network latency. It will show you garbage collection. It will show you a whole lot of the capabilities and where your time is being spent. This is a slightly out-of-date deck that says this is being added in Update 2. This, of course, Update 2 has been released. So everything that I'm showing you here has been released. Okay, so I'm going to switch over to an application that we wrote to demo this. And it's a fairly simple little application. Now, one of the things to be aware of when you're writing and debugging JavaScript applications for Windows 8 is the application is optimized by the JavaScript engine. So it's very much, you can think of it like managed code, right? So when your .NET application runs, the first thing that happens is it gets JIT optimized so that it runs much, much faster than if you're just interpreting all of the code. When you're debugging a JavaScript application, it has to run in interpreted mode, so it's going to be running slower. When you actually run the application from the desktop, or if you start it in Visual Studio without debugging, it's going to run optimized. So typically what I like to do if I just want to run the application and I'm not going to debug it, I'm going to start without debugging because I'm going to get a lot of performance gains and it'll run a lot faster. So this is a very simple application. What it does is it just shows a bunch of different graphics. These 2 daily images are being pulled off of my Azure website, and I can click at them, and I can see a larger image. So this is my little pond tool. Okay, so let's go back in here, and what I want to do is we now have this JavaScript analysis option under the menu, and I want to look at UI responsiveness. So I'm going to do that by launching the startup project. You'll see I've also got launched the applications or attached to a running process. We have either of those as well. And I'm just going to jump back to Visual Studio immediately, press stop, and it's going to do some analysis. Now you can see here's all of my startup code. In fact, let me stop this. And I'm just going to start this again so that I can jump back to Visual Studio much quicker. Initially, what you can see here is here was all of my startup code. It all happened, well within 2.5 seconds. I didn't interact with my application, and down here we had some garbage collection happen, right? So this is the JavaScript garbage collection engine where it kicked in, it cleaned up some of the stuff that was left over off of my initial startup. We can see we track using different color codes, loading the application, a bunch of the scripting that happened. There's some styling, some image decoding. On the CPU utilization, I've got the 100 line, and it's dotted over here. The 100 is 100%. And you can see I'm going over 100% in a couple of cases. This is where I'm actually using multiple cores of my computer. So depending on how many cores you have, you may see it go up 100 or 200 or 300%. Right? So that's just core utilization. The other thing that you'll see down here is we're also tracking your frame rate. Now this is going to be particularly handy if you're looking at developing something like a game, where frame rate is going to be very important. So I'm tracking CPU utilization and what it's doing in those IE subsystems. I'm also tracking frame rate for my application. So let me just run this again, and I'm going to stop it right very quickly. I'm going to launch that, go back here, and I want to stop, just so that we can really look at all of that startup. So you can see it's much larger now. So at about 1 second, everything was completely done. In fact, you can kind of say at about 600 milliseconds, my application had finished all of its startup. We can look in this, and I can see the orange, a lot of the time spent in startup was spent in scripting. Other thing where we spent a lot of time, there was some image decoding. So in a more complex application, it's really important to kind of look at where are you spending all of your time. Are there opportunities to optimize your code, your JavaScript, or whatever it is, to increase or decrease your load time? Now down below, we have all of the events that occurred as they occurred. So we can look at we initially had some CSS calculation, then some layout occurred. But what's more interesting, if you sort them by duration, I want to see what were the longest things that occurred. And when I sort by duration, the first thing that bubbles up is some HTML parsing. And that took a little over 200 milliseconds. Let's drill into that. If I drill into HTML parsing, we can see I've got some style sheet parsing that went on. There were some script evaluations. And then this one down here, the one that took the majority of my time, is 165 milliseconds. And you can see the name of the JavaScript file that was being parsed on that tooltip, or if I just expand this out. Although I don't have enough screen space here. But it's the ext-all-dev.js file. So a lot of time was spent parsing that. What this gives you the opportunity to do is optimize that JavaScript. So let's just stop looking at that and see how I can optimize it. Now, I happen to know that this particular JavaScript file was something that I used initially. I stopped using that library, but I left the reference in. So now what I can do is I can just comment that out because I'm not using that script. Or really what I would do is I would just delete that reference so that I'm not loading that JavaScript library anymore. Or if you still need it, maybe there are only portions of it that you need, and you could make it into a smaller JavaScript file. So this is where you can look at, how am I using the JavaScript? How can I make the best use of it? Am I loading too many files for the capabilities that I'm actually using out of that library? So if I just remove that, and we run this again, and we go back and we stop, you can see immediately that the amount of time that was spent in scripting is greatly reduced. You can also see that my initial loading now is down to about 400 milliseconds, which is what we'd expect since we saw that just parsing that one JavaScript file was taking 200 milliseconds. So we've reduced that. So we've sped up our application. Now, obviously, in a much larger application, there are going to be a lot more opportunities to really look at where am I spending my time, how can I reduce that time, what things can I optimize. So if we dig into this a little bit further, some of the other things that we can look at are image decoding. So I'm spending some time in image decoding. And when I look at these, the ones that are highest up to the top are these daily images. This is tropical fish, swimming fish, tropical reef. So I can also look at how am I using my graphics, right? So a lot of time is spent decoding my images. I can look at using thumbnails perhaps instead of using the full graphic. Right, so in a lot of cases what you do is you'll load up a larger graphic image and then you'll scale it down to a smaller size for rendering within the screen. Well, doing something like that is going to take a lot more time in my image rendering than if I loaded up a smaller image to begin with. In this case, the time isn't too bad, so we can ignore that for now. But this gives you a lot of opportunities to look at where's my time spent, how can I start to manipulate those things, and it'll also show you the exact files that are being loaded at the time that they're being loaded. Okay. Let's actually run this application a little bit longer and see what happens. So I'm going to look at one of these ponds, and one of the capabilities that I added into my pond is to be able to show ripples. So if I just click, we can see there's some ripples that appear wherever I click my mouse. And I thought, oh, that's kind of a cute little feature to add. Well, let's see what that actually does to my frame rate. So you can see now that when I was doing that, I'm executing a ton of scripting code, and my frame rate has dropped down to 16 frames per second. So it was typically up around 62, and at some points it got down as low as 11, We can see 10 there. And during all of that time, I was executing a lot of script. So just running this tool, looking at your application, you can really understand what's going on. Now, once I see that I'm executing a ton of script, that's obviously what's causing my slowdown. I need to look and see where's the time being spent within my code. This is where we actually have to switch into another tool to look at the profiling of my script code. So we have this start performance analysis and start performance analysis paused. Now, performance analysis is doing method-level instrumentation of your code to understand how much time is being spent within every method execution. This is a lot of data. It can cause your application to run much slower because of the amount of data that's collected. So typically, you're going to want to start the analysis paused. Now, when we start the application, you can see it's going to take a lot longer to load up, to really begin, because of all of the instrumentation that we're doing. So we're injecting our profiler into the JavaScript engine, and we're tracking all of the time. So even though I started at pause, there's still a cost at startup. Now, what I'm interested in is understanding the cost when I was clicking to make those ripples. So now that I'm ready to actually start collecting the data, I'm going to go back to Visual Studio, and you can see it's currently paused. What I want to do is I want to resume profiling, go back to my application, start doing some clicks, and now you can see it's running very slowly, and this is because of the profiler that we introduced. I'm going to go back to Visual Studio, and I'm going to stop profiling. So this is going to stop my application. It's going to remove the injection. It's going to take all of the data that I gathered, and it's going to do a lot of analysis on it. It's got to parse all of the data. So the longer that you're doing your collection and the more complex your application, the longer this step is going to take. So you can see that it's still spinning. It's still figuring this stuff out. It's analyzing my file. And once it's done, it'll open up this report. So we still have a little warning. So you can cancel out of this as it's taking too long. So if you recorded it for too great of a period, you may want to go back, record for a shorter period of time so you can get a little bit more performance out of this. It does take a little bit of time, but once it comes up, you'll see that we've got very, very rich data that will help you understand where all of that time was being spent within my application. And this is my favorite part of the demo because you always have to try and keep talking while everybody's staring at a screen that isn't doing anything. So if you have any questions, now's a good time. Feel free. Nothing, huh? Okay. It's a small crowd. Okay, great. Thank you for saving me. So I can't hear you very well. Let me repeat back and make sure I understand. Can I make it more fine-grained and focus on a more specific piece of the application? Is that kind of what you... Okay. What we're doing right now is it is more of a global thing. So it's the only way that we have of adjusting that is by starting paused so that we're not collecting, and then start. So it's, but as far as which code is being instrumented, right now it's global. Okay, great. Thank you for taking enough time for this to come up. So since he asked a question that saved me from watching a screen that was doing nothing, I brought M&Ms from Seattle. That gentleman gets M&Ms. Now, the gentleman in the white shirt, you may want to watch out because that's the thing. Oh, see? Pass those back to the gentleman. I have more M&Ms, so I encourage questions. All right. So we've now stopped collection here. And what you can see is we're doing the hot path. If you've used the profiler that's shipped with previous versions of Visual Studio, you'll probably recognize a lot of this. So what we're showing here is I've got my ripple method, which is calling math.floor. And math.floor is one of those built-in functions, right? To just, I need to do some math on my graphic images. And we can see that it's taking 40% of my time. That's really the slowest method that I'm dealing with. So this is a high-level summary page where you can kind of give you that instant snapshot view of what was going on. We can look at other views. You can look at things like the call tree. And if we expand this out, drill down into that ripple method, and if we look at that math.floor, well, one of the things that I notice here is it was called just a little over 60 million times. So that's an awful lot, right? And particularly if you're looking at things like games or anything that's graphic intensive, you want to keep your frame rate as high as possible. It's really important to start to look at how can you optimize things and where are your opportunities for optimization. So I can see I've got a problem with math.floor. I can right-click on a method and I can show the function details. Now this is just another view on top of the same data. We can see the top of the call stack, it called into ripple. And then we can see there's the function body took 57% of the time. Floor took 40% of the time. And what we do is we load up your source file right below directly to that ripple function. So from here, I can click on this, and it'll load up that particular source file directly into the editor, so I can start to look at this ripple function and try and understand what I can do to optimize this. Now, of course, what we're doing is we're just pointing you in the direction. You still need to do the hard work of figuring out how you're going to optimize something like math.floor. Now, one of the challenges with using something like math.floor is this is one of the core system modules, right? So I'm actually transitioning out of JavaScript into native to do these calculations. Since this is one of our core libraries, we do a lot of security checking and validation of the data that's passed into the method. So there's a lot of work that goes on with math.floor. Now this is my application. I'm passing the data to it. I know what's going on. I don't need the overhead that's incurred with math.floor. So I want to look at ways that I can get around using math.floor. Now, since this is graphics manipulation, and if I start to understand that and I really drill into how this stuff all works, I can understand that instead of using math.floor, I could simply replace this with a bit shift, and I'm going to accomplish the same thing. And the bit shifting is going to stay within the JavaScript engine instead of farming out into a core library down into native code. So I've got just a little snippet here that I'm going to drop in instead. And you can see this used to say math.floor. And what I'm doing instead is I'm just doing a bit shift instead. So wherever I was doing math.floor, I'm going to bit shift instead, and this is going to be a lot faster. So I'm just going to copy all of this code here and replace my pool code with this. Let's make sure it's the same thing. Okay, so now that we've replaced that code with my bit shifts, let's try running it again and see what happens. Now, I'm going to keep it to just one ripple so that this comes up a little bit faster this time. So again, start performance analysis paused. Wait for the application to come up. And we saw last time that this took a little bit. I'm going to go back to my pond, back to Visual Studio, resume profiling, click once, and stop profiling. Now, since I only clicked once, obviously there's not nearly as much data, so you can see this came up much, much faster. And you can see I'm not using floor anymore. Most of my time is still spent in Ripple, but that's okay because that was the only code that I was really instrumenting at the time. Let's see what it looks like if I do my UI responsiveness now. Come in here. Well, it certainly seems, to me, it feels like it's faster. But you really want to be able to look at the tools and look at the numbers to see if it actually did improve. And we can see that we went from 10 and 11, I've jumped up to 19 frames per second. So you can see that I've improved I'm not using quite as much scripting, and it has gotten better. So you can continue to look at how is your application behaving, what's the minimum bar, is 19 frames per second good enough, do you need to look at something else, do I need to analyze how am I actually generating those ripples so that I can optimize them even more, or is this going to be good enough for my customers? So there's a lot of tools here that you can use to really dig into your application and understand how it's behaving, and we'll point you to the code that's running slow. Okay. The next thing that I want to show you is a tool that ships with the SDK as well. Oh, see, now I get internet. Now, it's in this location. This is where it actually drops, and this is not the most intuitive location to go looking for a tool. It's a command line tool that can be used to actually look at the behavior of your application and understand how ready is it to submit to the store. So this is my app perf analyzer for JavaScript. It's a little executable tool that's provided for free from the Windows team. And you can see when I install Visual Studio, it gets dropped into program files, Windows kits, 8.0, under the bin directory. And you want to run under the architecture of your computer, not the target application that you're building for. It will take care of choosing the correct architecture of your application. You want to choose the architecture of your development machine. And then from there, under App Perf Analyzer. So it's a non-intuitive location, but unfortunately, that's where they decided to put it. So when I start this, one of the things that you'll notice, is I ran into an exception. Okay, I may not be able to show this. Unfortunately, I had Visual Studio 2013 installed as well, and there's a conflict between those two with the earlier bits that I had. Try it one more time. Yeah. Okay. When you run this tool, what it does is it's going to ask you a bunch of questions, and it'll ask you to interact with your application. So it would spin up. I should have had some screenshots as a backup, and unfortunately I don't. It's a very simple little application. It'll say, start your application. So you would then start my pond application. I would start it up, and then I would shut it down. And then it would say, now go to step 2. Step 2 is start up your application, interact with it, shift it into the docked mode, then close it, and then come back to this application. And it'll have you interact with your application several times. And it's a multi-step tool, so it's a very simple tool. And it collects a lot of data while it's running. Now, the reason I had to run this as admin, because it prompted me for my UAC controls, is it's using a lot of ETW, event tracing for Windows, for the data collection. And to be able to gather that data, you need to be running as an admin on the box. So it's going to run through. It's going to capture a lot of information. And fortunately, I did save the output files. So I can show you the results of what that looks like. So after running this, you get this HTML report that comes back from the application. And these are all things that you're going to want to fix or address before submitting your application to the store. Now, this isn't the same tool that the store team uses to actually validate your application. It's a little bit different, but it does check a lot of the same things that they'll be checking as well. So you can see I've got a few failures here, and I've got a few warnings. Now, I can drill into each one of these, and it's going to go into some details. Now, the first thing that it's saying is I didn't run this application on the correct hardware. And really what they want you to do is they want you to be running this on more of a tablet device in addition to just a laptop to make sure that you're taking advantage or understanding the impact of what an ARM processor would be like for your application. Now, if I'm not concerned about how this would run on, like a Surface device or an ARM processor, you may want to ignore this step, but it's something to be aware of. You could also run this same test on an actual ARM device. You can see I also got some image scaling warnings. So I'm doing a lot of scaling within those images, right? We talked about that earlier, whereas some of the other tool was showing me I was doing a lot of scaling, loading large images and then scaling them to be smaller. So you don't want to do that. And I've got some memory footprint errors as well. Now that's interesting because it's a fairly simple application, and I wouldn't have expected it to be memory intensive. So now that I understand that I might have some memory issues within my application, what I'm going to do is I'm going to switch back to Visual Studio and take a look at some of the memory analysis tools that we're providing. So again, under the debug menu, JavaScript analysis, we've got memory. Just like UI responsiveness, I can launch an installed app package, I can attach to a running app, or I can just launch my startup project. So I'm going to do that. Let's just jump back, and I'm going to take a heap snapshot, right? So I just clicked on that big button. And the first thing I can see is during startup there, obviously I increased a little bit of memory. That would be expected as you're starting up. And I'm running at about 42 megabytes. So maybe that's okay. You may kind of look at that and go, well, that's interesting. Why am I using so much memory? So from within this snapshot, I can drill down into the heap, and we're actually going to start to show you where all of your memory is being consumed. Now, with a JavaScript application, global isn't necessarily all that interesting because that's just going to be all of it. But we can see elements that are holding 7.91 megabytes. Here's this image, so I can see I've got an image that's actually consuming almost 8 meg. The way this tool works can be a little non-intuitive. So I'm seeing the size of these things, and this is what I'm interested in examining. So I selected my image. Down below here, we're showing you the reference graph for that object. Now, the children of image in the section below are actually the objects that are holding the references to that. So you can understand who is holding references to that image. So this is sort of working backwards. And eventually I drill down, and there's that list view. So as I display those images in 2 rows within my application, I'm using a list view control, and I can understand what things are holding on to what objects. Now, in this case, the simple solution, like we've seen before, is to use a thumbnail instead of that full image, right? So start off with something smaller. That's going to eliminate my scaling problems, my image scaling problems that I have, as well as some of my memory issues. Okay, so let me just stop this. And we're going to take another one. So we come in here, here's my startup. Let me take a snapshot. And then let's interact with the application. There's my pond. Let's look at another pond, maybe create a few ripples. And then go back to the start screen and take another heap snapshot. Now, it would be my expectation that if I started at the start screen, drilled into one of my ponds, went back to the start screen, went to another pond, came back to my start screen, at that point my expectation would be I should be at memory neutral. Wherever I started, I should have released my memory that I consumed as I was looking at the individual pond, and then come back. All that memory should be released, so I should have dropped back down to that, around that starting area of about 42 meg. And what I'm seeing is my memory consumption has gone up to almost 80 meg, and it's not coming back down. So that tells me that it looks like I've got a memory leak. What we can see between the 2 snapshots that I took, I've increased by 28 meg, and I've added 84 new objects. So if we drill into this, what it's going to do is it's actually going to bring up a diff between the first snapshot and the second snapshot. So I can actually have a comparison, so I can understand what are those things that are leaking. And you can see right here, well, I mean global again, I mean that's everything, so that's a little hard to understand because we want to scope it down a little bit more, but we can see where the size has increased. Now once we get down a little further in the graph, the numbers become fairly small, so they're less interesting. So we really want to focus kind of at the top. And we can see ripple appears to be the cause of some of my memory leaks. And if we come and drill down into these, we can see it's a callback. Now this is one of the most common memory leaks in .NET, and the same thing is happening in JavaScript, right? You create a callback handler for some event, and every time your page processes or your screen processes, you add another handler onto that event without releasing them. So we're seeing the same thing happen here. I've got a callback handler, and it's hanging on to a reference within my ripple method. At this point, I need to then go into my code and start to examine, what's going on, where am I holding on to these references, and how can I start to make sure that I'm cleaning those up a lot better. So if we take a look at this little snippet of code here, what I've got is I want to add in a little bit of code that cancels some of these callbacks. So I'm just going to copy that. And this goes into my pool class. Now, as you start to explore these things, what you'll start to find are different objects that start to become referenced all over the place. And the big problem that I have within this application is I've got a reference to an object, and I'm just trying to find it here. Oh, actually, I believe it is in my pond. Yeah, it turns out as you start to drill in through these and dig into them more and more, that this water element is going to start to pop to the top. So you need to start looking at how do I remove my callback handlers. Once you've added those, you run the tool again. From there, you'll start to see this water object starts to bubble up to the top. So now that I've got my callbacks removed, we can run this again. Oh, still running. I want to take a snapshot. Actually, I should do that before. If I take another snapshot, we can see I'm not leaking quite as badly, although I didn't take it quite at the same time. And as I drill down into these elements, you can start to see where things are being held onto, and some of the divs and the sections and the main divs in my canvas. And it becomes an iterative process where you continue to make fine changes, rerun the tool, understand where your leaking is coming in, and modify your code. But with these tools, we're showing you which objects are holding the memory, and then which other objects are holding references to those objects. So it's a very complex graph. It can take a lot of sort of playing around with it to really understand what's going on. But the key thing to think about when you're looking at this is this div is being held onto by these things. So it's sort of like a reverse graph. So both of these objects here are holding a reference onto that div. All right. So that's a lot of the memory tools that we've got, and you can continue to take heap snapshots, and you can continue to do differences between the two of them. What's nice to see is even just with this cancel, I've reduced my memory footprint by 477 objects, even though my memory has still grown. All right, let me just switch back to the slides. So we've got instrumentation-based profiling, right? You want to be careful when you're running that one just because the amount of data that can be gathered. So it's a lot of information, it's very valuable, takes a little bit of time to render, but once you see that, it can point you back to your code on how you want to optimize your code. And with the profiler, unlike some of the earlier tools I was showing where it was all of the IE subsystems, the JavaScript profiler is strictly about your JavaScript code. Some of the other things that we want to go over here, and you may have seen them in the demos, is this concept of inclusive time versus exclusive time. These are terms that we battle with, and we've tried a couple of different ones, but they're hard ones to sort of understand and explain without sort of having a presentation where you can do this. Now, what you'll see is you'll see these two terms used fairly often within the tooling. Now, just as an example to help explain inclusive versus exclusive time, we can look at two methods, alpha and beta. Alpha takes 30 milliseconds to execute the code contained within just alpha. It then calls out to beta, and beta takes 50 milliseconds to execute. So when you look at the exclusive time for beta, it's 50 milliseconds. So that's how long it takes for the code within beta to execute. Inclusive time would be the same in this particular example. Exclusive time for alpha is 30 milliseconds. Inclusive time is 80 milliseconds. So inclusive time is how much time does it take my method to execute its code as well as all of the child methods that it then calls. So when you look at these terms within the tools, understanding inclusive versus exclusive is fairly important. We've already done the demos for that. I showed you the performance, well, I didn't show you the performance analyzer tool, but I showed you the output from the performance analyzer tool. And the things that it looks at are your activation time, your UI responsiveness. We saw that it looks at memory consumption, image scaling, your footprint for your memory, a bunch of different things. So that tool will look at all of these different characteristics within your application. Strongly recommended run that tool before you submit your application to the store. It'll save you some grief of having your application rejected based on some of these. And then the next thing that we looked at was the memory profiler. And we've got some terminology to go over on this as well, just so that you understand, as you're looking at these tools, what these numbers necessarily represent. So size is how large the object is in memory, and retained size is how much memory the object is keeping the garbage collector from reclaiming. So this is best served with a graphic. Now, I've got object A, which is 100 kilobytes in size, and it holds a reference to two other objects, B and D. B being 500K, D being 100K. Object C is 50K on its own, and it holds a reference to object D. So we've got size and we've got retained size. Of course, the size is fairly obvious. Retained size is not so obvious. So the retained size for object A is 600 kilobytes, which is not necessarily intuitive. You might think that it should actually be 700 kilobytes. But it's only 600 because if you remove the reference to object A, the garbage collector would then also be able to reclaim object B. The garbage collector would not be able to reclaim object D yet because object C still holds a reference to it. So the retained size for object A is 600K. Obviously, the retained size for object B is only 500 because it doesn't have any child references. Object C's retained size is 50K because object A is also holding a reference to object D. Now, if object A was removed and its reference to object D was eliminated, then the retained size for object C would become 150 because it's the only thing holding a reference to D, which means if you get rid of object C, the garbage collector can reclaim 150K because it could reclaim object D as well. And then, of course, object D is 100K. So that's why in the memory analysis tool, when you select an object, we show you all of the parents. So if you had selected object D in the reference graph at the top, we would show you that it's being held by 2 parents, A and C, so that you can understand what it's going to take to reclaim its memory. Okay, that sort of wraps up everything. There's a lot of new tools. There's a lot of very interesting technology going on with JavaScript and Windows Store apps. Hopefully these tools will really help you develop those applications. Any questions? Yes, sir. Say the very start again. Okay, so you're looking for, do we have a standalone tool that you can use to gather this information and then bring it back? A lot of these tools we're looking at adding for standalone. I'm not entirely sure what's available for the JavaScript. We will be introducing memory tools for .NET as standalone. We should have these things shipping standalone fairly soon if we don't yet. But it's something that we're very interested in providing so that you can gather the information externally and then bring it back yet. So some are available today. More will be coming as we continue to add them. Yeah, great. I have M&Ms for you. And you're at the front, so I shouldn't hit anybody else when I throw these. I came close. Great. Any other questions? Great. Well, thank you very much. I think lunch is going to be served very soon. Thank you for coming.